Oh, I guess I just want to mention this. Subscripts. Subscript, I guess you could call it a subscript trick to identify dimensions. And this is what my friend Omar was saying a second ago. If we have a element of R m by n, we can write a, and I like to put braces, m by n, to identify dimensions for ourselves. No self-respecting Southerner used instance grits. No self-respecting linear algebraist would do this in a paper, because if we've identified it somewhere else, why would we identify it again? This is much more of a Jeff Anderson thing that I use in my life, and that I found many other people use, at least in their head. I encourage my students to write it down specifically. Notice, however, where is the dimension written? Is it written in the superscript or the subscript? Write it in the subscript. If you write it in the superscript, that actually has meaning, and it's not the meaning that you're intending. Right? So you can take powers of matrices, and those are non-trivial things. This is a heuristic to allow us to get in the habit of specifically identifying what the matrix looks like, because that gives us hint into the structure of the problem. If you write that in a paper, people will probably laugh at you, so don't do that. When you write it in your notes or on a test or any other situation where you see it and you're working out problems, I will give you big kudos, because you're training yourself how to actually see dimensions of matrices. Yeah, go ahead.
Do you recommend to write those in tests in like future classes?
I mean, you could. It depends on how far you are along. If you can't immediately see it, then write it down. And hopefully you've triggered yourself. This is actually a trigger for me. Like when I write that down and I know what m in and I know what n is, there are many, many things that run through my head the moment that I've written that down, and I find that quite helpful, right? But the other side of the coin is, at this point in my life, I don't have to write that down, and I will already see them. So I would say, if you write it down, be a little bit careful. Maybe write a little note for yourself so your teacher can't be too picky, right? And then use it for your benefit, right? Okay, so here we go. We're going to talk about the entries of a matrix, and we already talked about this a little bit. Okay, this one's kind of exciting, actually. Could you guess what we say a zero entry of a matrix is? An entry. Could you guess what's true about a zero entry? Yeah, it's an entry equal to 0. Could you guess a non-zero entry of a matrix?
Wow.
Is an entry AIK definitely not equal to 0. Very good. This is in lesson, I guess it's lesson 8 on page 1, bottom of page 118, top of page 119. Wow, you have a color printer. I'm jealous. I want one of those. We're going to define a leading entry, and we'll come back to this later, but right now I'm just doing a bunch of notation because we're going to come back to this throughout the quarter, of a row in a matrix is the first non-zero entry in that row when reading from left to right. Okay, and then this is, so when we say the first, this has special meaning. What does it mean first in terms of column index? So try to restate this thing using the phrase column index rather than the first leading from left to right. What would a leading entry be? How do you find leading entries?
From left to right, so it's a column.
Focus on one specific row and then do what? find, out of all non-zero entries, find the one with the smallest column index. This is the non-zero, this is, I guess, a non-zero entry of a row with smallest column index.